What up, pre-calculus students? Mr. Mester coming back at you from his classroom. Talking about inverse functions. I've been dealing with inverses for a long, long time. Since Algebra 1, when you were asked to solve an equation, you were actually like actively using an inverse. You were undoing what was being done to x. And that's what inverses do. They undo what's being done. We've learned progressively through math classes about more and more inverses, like a square root function undoing a square function, and then more recently, a logarithmic function undoing a exponential function. And the key is the concept that if your function, when you plug A into its machine and it outputs B, the inverse function will take that B, plug it into its machine, and bring it right back to A. So it's almost like thinking about, our machines. F will take A, bring it to B. F inverse can take that B and bring it back to A. What we don't like to do is really do like X's and Y's. Some math classes teach you like flip-flop the X's and Y's. It kind of gets confusing. I don't like to do those. I like to stick it with A's and B's. For example, like if F has an point AB, the inverse has to have the point BA. A is going to go to B, input, output. The input of B has got to go back to the output of A. Okay? So essentially, you're flip-flopping, but like we don't want to say flip-flop the X's and Y's. It can get confusing as like the meanings of them could change. So we're just going to stick with like A's and B's. If these are A's and these are the B's, these are your inputs or your outputs, you would take your outputs, plug it into your inverse, and it'll bring it back to the input. Like if you plug in -5 and you get -10, I'll plug in -10 into the inverse and it'll bring me back to -5. I'll plug in -5 into the inverse, it'll bring me back to -3. I'll plug in -3 back into the inverse, it'll bring me back to -1. I'll plug in 1, it'll keep it at 1. I'll plug in 2 into the inverse, it'll bring me back to 3. So it's like, here is A plugged into machine F, gets me B. We then take that B, plug it into F inverse's machine, and it brings me back to A. That's undoing what's being done. Reverse engineering your program. We like to kind of list things in numerical order. Like you could say, oh, -2 is going to go to 8. That means like plug in 8, you're going to get -2. And I'm actually fine with this. However, it's probably better to pay attention to like the order. Like I'm going to plug in -10 as my input. My output's going to be 7. Some things we notice, is that the domain and the range are flip-flops of each other. The domain for the f function will be the range of the inverse function. The range of the f function will be the domain of the inverse function. These are things we can think about and use. It's kind of the same thing here. I don't want you to like flip-flop or reflect over the y equals x axis, though it's true. I'd rather you just say like, okay, I have an input of -1, -2, -3, -4, -5, an output of 1, 2, 3, 4, 5, 6. This is an output of 6, 5, 4, 3, 2, 1. If I have the input -5 goes to 6, that means I need an input of 6 to go back to -5. So this is 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5. I'm certain you guys are just all like, oh, just like flip-flop the points. And it's like, yeah, you are, but I'm thinking of it more in terms of machines. I have -4 going to 3. That means I'm going to input 3 and it'll go to -4. if I wanted to find any point in between, you could then look at any point in between. Reversed. We got -3, 2. Input 2's got to go back to -3. I got -2, 1. Input 1, you got to go back to -2. I have input 1, output 0. Input 0, output 1. This would be the graph of F inverse. Okay. Cool. Understanding A's, B's, the inverse has to have BA. Don't think about it as X's, Y's. A's and B's, B's and A's. Domains and ranges are going to flip. F's domain are all the X's that we use. All of these points are X's in between -2 and 1, 2, 3, 4. So the domain are all the X's between -2 and 4. And if you'd like to, you can use inequality notation, which would include -2 and 4. The ranges would be all the Y's that I use. All my Y's are -1, -2, -3, -4 to 1, 2, 3, 4, 5, 6. I am using X and Y. I kind of want to use A and B, but that's fine. The domain and range of the inverse is going to flip. Okay? That means you would have your inputs of your range plugged into your inverse, and it would output your domain. It's like going back from our output back to our input. So the domain is going to be the range of the function. They switch to X's. This is where it's confusing. It's like, oh, these are X's, but these are Y's. It's like, that's why we don't like to use X's and Y's. What's the max and minimum values of F inverse? Well, the minimum and maximum input would be the minimum and maximum output of F inverse. Like if we have points that are flip-flopped, A goes to B for F, B will go back to A for F inverse. The A's, therefore, are the output values of F inverse. Like we have the F inverse of B equals A, F of A equals B. Think about how like things will flip-flop. This -2 value would be the minimum value. It would be the F inverse of -4 equaling -2. That would be our minimum value. Our maximum value would be 4, but we would have to input 6 to get that maximum value of 4. Okay? All right, now we're finding some different values. F inverse of 2. I want to think about like what are different ways to show you this. I do this in my calculus class. Like F has the point blank blank AB. F inverse is going to have the point BA. Maybe this helps you get started and then you'll kind of do the rest. So I'm trying to find F inverse of 2. That's when B is 2, like when you're inputting 2 into the inverse. Well, that corresponds to F's output being 2. So I kind of start with this being like, oh, to find F inverse of 2, I need to find the input of F that outputs 2. It's almost like I look at the y-axis. I see, oh, when y is 2, I have x equals 3, I have this input 3, output 2. That means f inverse of 2 has to be 3. We have to flip-flop the points, undo each other, so we get 3. So you're going to kind of think of that and be like, oh, I'm just going to kind of like look at the y-axis, and you'd be correct. Like f inverse of -3, you would look for when f's output is -3 right there, and you would find the input. Now, this is using slopes to make sure that we're going up 2 over 1. The slope of that is up 2 over 1. I need to go up 1, divide the top and bottom by 2 over a half. So this is going to be -1.5. Just to kind of confirm things, like f's got the point -1.5, -3. F inverse has to have the point -3, comma -1.5. That's using function notation. If you want to use points, this is what I do. In my calculus class, I say f's got the point -1.5, comma -3. F inverse has the point -3, comma -1.5. Okay. So we're good. When is f's output 1? That's when f inverse will have an output. What is the input when f's output is 1? That will be the output when f inverse's input is 1. It's very confusing, but I'm sure you guys are kind of figuring out. We're looking for when f has a y coordinate of 1, or when it's outputting 1. I look up here to the graph. I see right here. I need to use my slope. I go up 1, 2 over 1, 2, 3. The slope of that line segment is 2/3. I need to just go up 1. So that's when the top is 1. So I'm going to divide the top and bottom by 2. That means I'm going up 1 over 1.5. You have to be able to figure this out by taking your slope and manipulating it. You're not guessing. It is 1.5 or 3/2 because you figured it out. All right. One is f's output 5. I'm just going to go straight to it. Here's 5. Here's that point right there at 5. My slope here is 1, 2, 3, 4, up 4 over 1. I need to go down 1. So I'm going to divide the top and bottom by 4. So that's 1 over 1/4. So I'm going to go over a fourth from 3. That's 3.75. F's got the point 3.75, comma 5. F inverse has to have the point 5, comma 3.75. It's got to go back to where it started. F inverse -5. Okay, here's a good question. When does F have a output of -5? We don't see it. You can't assume that this line's going to go on for forever and ever. Like, if this is the graph of F and it's defined between these two x values, it has this domain, it has this range, this cannot be found. Unless I'm thinking crazy. 1, 2, 3, 4. No, like I can't. F inverse of -5, I don't know. Why did I do this then? Again, if like the first one's undefined. Maybe I wanted it to be +5. Well, the answer right away is undefined. I'm just going to switch it up to be 5. I think that was the intention. We already found f inverse of 5 is 3.75. Now we have to find f inverse of 3.75. Now, that's not going to be easy, but we can do it. So 3.75 is right here. Whoosh. That is up 1.75 from 2. 1.75 is 7/4. So I'm up 7/4 from 2. My slope of that line is 4. I want to change that to 7/4 to figure out how much I'm moving over. 4 times what? 7/4. 1/4. 4 times what is 7/4? 7/16. So multiply the top and bottom by 7/16. I go up 7/4 over 7/16. So I'm going over 7/16 from 3. I bet you that's going to be right. So 3 plus 7/16, whatever that is. I don't want us to stress out too much about that. We can do the math, figure out what is it, 48/16? 55/16? That might be right. I don't know. That's a little bit too much for you guys. Now, this is the last one. I'm glad we're doing this last one. This is a fun last one because, if you're not thinking, you're going to do a lot of work that's unnecessary. And we have a couple of these down here. F and F inverse are inverses of each other. They're going to undo each other. If you look at this, if F and F inverse are inverses of each other, if they're going to undo each other, F inverse of -2 will get you, some A value, and then F of A is going to get you that B value that you started with. We're going to undo each other. The F and the F inverse are going to go away. I know the answer is -2. Now, if you do the work, let's see. When is the y coordinate -2? It's at -1. What's F of -1? F of -1 is -2. Oh, it's yeah, it's I looked at the output, boom, boom, went backwards. Unnecessary. Inverses will undo what's being done. Okay, here we're told this is F and G. You are not told that F and G are inverses of each other. That happens usually instead of defining F inverse and using the notation F inverse. Sometimes people say G is the inverse of F, but that's not the case here. These are just points on F and G. So, sticking to our ideas of F having a point AB, F inverse will have a point BA. So I'm trying to find F inverse of 1. That's going to correspond when F's output is 1. F's output is 1 when its input is -1. So F's got -1. F of -1 is 1. That means F inverse of 1 has to be -1. Got that? G and G inverse. G's got some point. I'm trying to find G inverse at 0. G's got some point where its output 0. G's got some point where the output is 0 at -3. So G of negative 3 is 0. That means G inverse of 0 has to be negative 3 to undo what is being done. Okay? Not going to show that. We're just going to move on. F inverse of 0. When the output is 0, the input is 2. F inverse of 0 is going to be 2. G inverse of negative 2. Okay, so G of G inverse. I mean, you go through this work and it's like funny. G inverse of negative 2 will be 3. G of 3 will be negative 2. Oh, we undo each other. This is not going to be the case, though. This is not 2. F inverse of 2. So, like, when is F's output 2? Here, that's at negative 2. So now I have to find F inverse of negative 2. I'll put that here. What's F inverse of negative 2? Okay, when is F's output negative 2? That's at 1. So we get 1. When is G's output 1? That's at negative 2. So we got G inverse of negative 2. Now we're looking at when G's output is negative 2. That's at 3. Don't do any work. Don't waste your time. If you want to, let's see. What's F of 0? F of 0 is negative 1. Oh, the inverse is going to take that negative 1 and bring it back to 0, back to where it started. Undo the program that was done. Okay, this one is good. F of 1. This is not F inverse. This is F of 1. So I'm looking when the input is 1. What is the output? When the input is 1, the output is negative 2. G inverse, we will look at when G's output is negative 2, that input is 3. So that answers 3. Don't waste your time doing any work. G of G inverse will undo each other. You just get 2. If you look at it, it's just like you're looking at the same point. When is the output 2? At negative 2. What's G of negative 2? It's 2. They just keep taking each other back to where we started. All right. Not sure how I want to teach this, but here's what Mr. Huffaker does, and I'll show you that. It's like, actually, this is what I'm going to do. I'm going to do this one. We're going to say F's got A's and B's, okay? So when you input A, you get B. That should be A. Okay? The inverse will take that B and bring it back to A. I need some expression where I'm taking B, plugging it into a machine, and it'll bring it back to A. I want to solve this equation for A. So that I have A equals a manipulation of B's. So I don't want to use X's and Y's. It confuses you, especially like a lot of teachers say, oh, just flip-flop them. And it's like, does make sense, but like when you flip-flop them, all of a sudden, like X's becomes Y's, Y's becomes X's, but it's not true. It's like if you think about F being like the dominating function, these are our inputs. These are what we're caring about. This has meaning. If you flip-flop them, they mean different things, and that's confusing. And we don't want to have that mistake in our brain. So I'm just going to stick with A's and B's. What Mr. Huffaker does is just solve for X. And just be like, here's your equation. X equals Y. So I'm going to use A's and B's. I like A's and B's. Okay, so I'm going to solve for A. I'm going to divide by 3, and then I'm going to take the log base 2 of both sides. Okay, this is your expression for F inverse. F inverse of B will equal A. You plug in a B value, you take the B value divided by 3, take the log base 2, and you'll get A. You plug in an input of B, you will output A. This is your expression. Some people would say, though we don't want us to be confused, but I think this is what you're going to maybe see on your test, is that F inverse of X, log base 2 of X over 3, but it's really like x's aren't x's, x's are actually y's. So, right, like this is an x, this is a y, this is a y, this is an x. Like it's confusing. So, I don't know. The other way Mr. Huffaker does is he says just solve for x. This is your expression. X equals log base 2 of your y's over 3. If you're looking at your answer, you just replace that y with an x. I'll do it both ways. I don't want to confuse you. D of A is 3 times 2 to the 3a minus 1 plus 1. That equals B. I'm going to solve for A to get the D inverse expression. So I'm going to subtract 1, divide by 3. Kind of undoing what is being done to A. I'm undoing the machine, creating a new machine. I'm taking the log base 2 of both sides. I'm adding 1, dividing by 3, and I get this expression. A equals log base 2 of B minus 1 over 3 plus 1 over 3. This is your expression for D inverse of B, which will equal A. You will take these values, plug them in. They are the outputs of D, these B's, reversed, engineered to go back to your inputs. You will undo what is being done to A. Like A is multiplying by 3, then subtracting 1. 2 to the power, then times 3, then plus 1. To reverse that, I will subtract the 1, divide by 3, log base 2, add the 1, divide by 3. That's like, this is the reverse engineered function. Okay. Let me do this one Mr. Huffaker's way. You'd say y equals 5 log 4 of x. Solve for x. I would divide by 5. 4 to the power of both sides. You get 4 to the y over 5 equals x. This is the reverse engineered. Take your y's, divide them by 5, take 4 to the power, and you'll bring them back to the x's. You would say g inverse equals 4 to the whatever divided by 5. And if you want to use x's, great. What I do is use b's and say, you take your b's. This is how you'll bring them back to the a's. Okay. You guys figure out a way to do it that suits you. I'm sure a lot of you are used to algebra 2, which is like flip flop x's and y's and then solve for y. But like, it gets confusing when you use x's and y's. So just solve for x. Undo what's being done to x. Undo h's program. Four to the y minus 1 over 5 equals x minus 2. Add 2. 4 to the y minus 1 over 5 plus 2 equals x. I like using a's and b's, like h of a equals b, which equals that equals a b. We solve for a. We'll have h inverse of b will equal 4 to the b minus 1 over 5 plus 2, which equals an a. Back it up. Okay. I'll go back to the A's and B's. J of A equals log base 3 of the log base 4 of A. That equals a B. I will solve for B. I will get rid of the log base 3, giving me log base 4 of A equals 3 to the B. I'll get rid of the log base 4, giving me J inverse of B, which equals A, which equals 4 to the 3 to the B. Do it the other way. Y equals 2x minus 1 over 3. Solve for x, undo the program, multiply by 3, add 1, divide by 2. This is very much what you guys do to solve equations. You know, you like the one step, like when you were solving equations, you were using the inverse. You were just doing it one step at a time versus like creating an inverse program. You can say this is C inverse of B, 3b plus 1 over 2, which will give you an A. It'll take the B, bring it back to A. It'll take the Y's, bring them back to X's, which is what we want. We don't want to say the X's are going to go back to the Y's. It can kind of get confusing if you're talking about C being the function. All right, cool. H of A equals 3 to the 2 to the A, which equals a B. Solve for A. I'll take the log base 3 of both sides. Take the log base 2 of both sides. I get this. This will be H inverse using B's, which will equal an A. The log base 2 of the log base 3 of B. Take your outputs from your original function, plug them into the inverse. It'll bring it back to the inputs. Doing it the other way, just solve for x. I would take the natural log of both sides, subtract 3, divide by 2. Boom. This is B inverse of y. This is your B inverse function. If you see on your test, you might see this with an x instead of a y. We're going to kind of stay away from that because it could get confusing. X's become y's, y's become x's, like blah. Okay. These are good questions. We are going to limit the domain. Okay, we're saying F only exists from 4 to 9. This is like what we're talking about with like if you're into programming. Like sometimes you need to say like, yo, we're only allowed to plug in these numbers into our program. We're only allowed to use these things into our program. If somebody tries to type in something else, we're going to say, no, you can't. It's going to break. So we're not going to let you type something in. Okay, we're going to limit values that are plugged in. Okay, what's important is to understand the range. Now, this function, square root of x, is an increasing function. It's increasing at a decreasing rate. We should know that. We know f of 4 is 2. We know f of 9 is 3. We know that the points in between would produce y values, output values between 2 and 3. So the range is between 2 and 3. Okay, now the inverse function would be x equals y squared. Or we'll say the inverse function, if you're using x's, is x squared. Like the inverse of the square root is the square. We don't like using that. I probably would want to say like f of a, which is root a equals b. If you solve for a equals b squared. This is f inverse using b. Gives you an a, it's b squared. So we're saying it's b squared. Now what's important about this is like the domain is now these output values. These are the values that we're going to plug in. 2 to 3. They are inputs. I don't want to call them x's. They are now inputs. And the range, the y's, flip-flop. So you plug in the range is 2 to 3, and you can see the whole flip-flopping nature. Like you plug in 2 into here, you'll get 4. You plug in 4 into here, you get 2. undoing each other. 4 goes to 2. 2 is going to go back to 4. Boom. That's inverses. Okay. Same thing with this. Let's see what's going on, and then we'll see how it gets really complicated going the other way around. Nine minus x squared square rooted ends up being kind of like a half circle. Don't worry about why. Just like trust in that we are giving you something that's going to be continuously increasing or decreasing, so this works out. Anyways, just like find the range. I got the negative square root of 9, which is negative 3. It's not plus or minus 3, it's just negative 3. And then I got f of 3, which is the negative square root of 0, which is 0. So my range will go from negative 3 to 0. You don't have to know what this looks like. Now let's find the f inverse. So f of a is negative square root of 9 minus x squared, 9 minus a squared. That equals a b. I'm going to solve for b. I will take the opposite of both sides. I will square both sides. I don't want to say that it's positive b squared, though it is. Like if I put negative b squared, this is the exact same as b squared. Like you can take the negative 1 and square it and the b and square it. So maybe we want to say this is b squared. I'm going to subtract 9. I will then take the opposite of both sides. And now here comes the fun part. When I square root, I have a plus or minus. This is something I don't think we expected. Now, this is not a function, but I'm asked to write a function. Okay, here's where the domain and the range comes into play. And we kind of talked about this in the lesson, I hope. So, this function, which is this f inverse of b, which equals an a, you could say it's f inverse of x's. If you want to do it, it's going to be 9 minus x squared. But it's like, you can't have a plus or minus or else it's not a function. So the question is like, what's going on here with this plus or minus? Well, let's pay attention to the domain and range of the original function. The domain was 0 to 3. The range was negative 3 to 0. For this guy, it's probably best if we don't use inequality notation, but we're going to. The domain has to be negative 3 for my inputs to 0. And the range has to be 0 to 3. Okay. My outputs, because of this function, my outputs need to be from 0 to 3. Those are positive values. Let's see. If I plug in 0, I have the square root of 9 minus 0 plus or minus. Well, no. I say that when I plug in 0, I better get an output of 3 because then we're going to have this input of 3 going back to 0. 3 goes to 0. 0 better go just back to 3. What we are going to see, guys, is you need to pay attention to domain and range. Make sure when there's ambiguity, when there could be a plus or minus, which is not going to happen often, but with square roots it does, pay attention to which side of things we need. Now, let's make sure this is correct. 0 has to go to 3. If I plug in negative 3, I didn't really care what the plus or minus is going to be. If I plug in negative 3, I would have gotten 0, even with the plus or minus. My answer here is the positive half of things, okay? Maybe this didn't make sense, but the next two, we probably should have done this one at the end. The next 3 are going to be like the same deal, where it's like, hey, make sure you pick the correct half so that we have a function, an inverse function. Again, think about programming. You want to be able to plug in something and output something, not multiple things that will break your program, or you'll output something that you're not expecting. So pay attention to the domain and range. X squared will output from 4 to 25. I know the inverse is going to be the square root function. If you wanted to do that, you could, but like the inverse function, square root x, its domain needs to be from 4 to 25. Now, I'm sorry, I screwed up. If I were to square root, and it's not going to be a problem, you would have a plus or minus. I immediately screwed up. F inverse is plus or minus the square root of your outputs. Okay, now not x, but like your y's. Your F inverse of b is the plus or minus root p. But we are told that if you plug in values from 4 to 25, which are positive, your outputs need to be positive 2 to positive 5. That's the domain here. The only way to get this positive 2 to positive 5 is to have the positive half of things. So your inverse is the positive half of the square root, not the plus or the minus. The next one you'll see is going to be different, hopefully. Okay. My range. If I plug in negative 8 plus 4 is negative 4 squared is 16. We might have to flip-flop things. Watch this. If I plug in negative 4 plus 4 is 0, 0 squared is 0. So I'm going to go from 0 to 16. But negative 4 got me 0, negative 8 got me 16. That's important to pay attention to because I've been kind of things have lined up, but it's not always going to line up. Okay, if you want to do the Mr. Huffaker way, you just solve for x. You square root. Now, when you square root, you'll have a plus or minus. Subtract 2. Plus or minus root y minus 2 is equal to x. Okay, so I'm going to take my outputs, my y's, square root them. I need the correct positive or minus side and have 2. So I can have my expression for my inverse. Maybe using x's would be plus or minus the square root of x minus 2. My domain has to be 0 to 16. My range has to be negative 8 to negative 4 to undo what's being done. Okay, so we flip-flop things and we pay attention to that. Now let's make sure it works out. If I plug in 0, square root of 0, 0 minus 2, that doesn't work. I should be getting negative 4. What the hell happened? I don't know why I did that. I was like thinking crazy here. Okay, plug in 0, plus or minus doesn't matter, minus 4, I get the minus 4. Yo, if I plug in 16, I better get negative 8. If I plug in 16, I square root it. Well, usually you say the square root of 16 is positive 4. Well, positive 4 minus 4 is 0. But what we're saying is that if you plug in 16, you better get negative 8, which is why we need to undo this function completely, to reverse engineer, to bring these points back to where they started. We need the correct half of things. And this is where inverses get tricky. Like understanding the domain and the range, understanding we want to exactly undo what is being done. So go back to the original, plugging in outputs from the original. Okay? Let's see what happens here. Range. Let's go ahead and I'll probably do the work down here. I wish I did that again. If I plugged in 3, I get 0. If I plug in 6, I'd get 3 squared, which is 9, but I get negative 9. So doing that first probably is helpful. Understanding that when you input 6, you output negative 9. When you input 3, you output 0. My inverse, I'm going to solve for A. I'm going to take the opposite of B. I will then square root both sides. Since I'm using a square root to solve an equation, I need a plus or minus. I will then add 3, and I get my F inverse of B, which equals A, which equals 3 plus or minus, we'll figure that out, the square root of negative B. Now I'm going to pay attention to my domain and range for this one. So for my inverse, I need to plug in values between -9 and 0. This is why I'm saying like sometimes don't like switch them. And my range has to be values between 3 and 6. If I plug in -9, I better get 6. If I plug in 0, I better get 3. If you'd like to use x's to kind of show that, go ahead. Now we need to plug in -9. When I plug in -9, I better get 6. If I plug in -9, I take the opposite, it becomes +9. I take the square root of +9, I get 3. I need to add that 3 to get 6. Okay, let's check at 0. If I plug in 0, I better get +3. Well, that doesn't matter. This guy needs to be checked. Plugged in needs to output 6. We need the positive half of things so that we have a function, not a non-function that outputs two different values. So my inverse function is the positive half of the square root so that I have my domain outputting my range. Tricky. And when we get to number 11, we kind of show you why we do this, why we do what we're doing. Because like you'll see, we don't want X's and Y's. It's confusing. It's like inputs and outputs, A's and B's. Okay. If g of x is 4, what is f of x? If g of x is 4, what is f of x? I think these are just easy questions that we threw in there just so that you know you're ready for this question that we show up on the test. 2, 4, 8, 16. F of x is just 16. What I am doing is essentially using the inverse to solve. So this is why this is inverses. If g of x is 3, what's f of x? Well, 3 cubed, 27 is f. If g of x is -2, f of x is 1 over 100. If g of x is e to the 5/4, f of x is e to the 5/4. I think we meant log 5/4. All right, last question. This is the question that's like the key. Like, why do we have inverses? Why do we want to do programs? Because sometimes we want like these programs that will kind of use outputs to go back to the input. A construction scientist produced a model to predict the amount of cubic yards of concrete needed to construct a parking lot with area square feet. So it's like we got a model that predicts the cubic yards of concrete based on an area. So you know the area, like think about landscaping. You have the area, okay, you have the area calculated, that's easily calculated using, just measurements. But boom, I now use a model to predict the cubic yards of concrete that I need. That way I can go to Home Depot and say, I need this much concrete to cover this area to make your driveway. What would happen if we have the inverse? Okay, so this is f of A equals C. Take your area, plug it in, you'll get your amount of concrete. I think we wanted to say, what is F inverse? F inverse. This is F. Okay? What is F inverse? Okay, so F inverse of C would produce A. So this is what would happen. Um, let's say Home Depot's got some sort of sale on concrete. They're like, yo, we'll give you this much concrete right now if you buy it in bulk. Well, what you could do is reverse engineer and be like, oh, if I buy this much concrete, I have this much concrete to handle this much area. So, like, you have the concrete first. You will then be able to say, oh, this is how many jobs I can do. The F inverse is going to take your outputs, your concrete outputs, and instead you're going to be like, yo, what if I had my concrete first? Then we'd be able to figure out how much area. So in a real life situation, you'd be like, if you purchase your cubic yards of concrete, you'll know, if you have your concrete, you'll know how much area can be filled. Okay, so it's like chicken egg kind of thing. Like that's what inverses are for. Like here, I go to the site first, I look at the area, I then go to Home Depot, get my concrete. Here, I purchase the concrete first, and then boom, I'll know how much area that I can handle. I try to pick up jobs to then be able to use all the concrete that I paid for. It's inverses. Outputs, inputs, inputs, outputs. Don't think about X's and Y's. That might confuse you. Inputs and outputs are confusing too. Anyways, good stuff. I didn't even have to use Desmos at all. Hope you understood. Good luck to me teaching this stuff today. Later.